Hi everyone, welcome to our talk. Welcome to the Jumble Improving RDP Tooling for Malware Analysis and Pen Testing. We're going to talk about a tool we built to leverage the power of being in the middle of a remote desktop protocol connection. My name is Emilio. I'm a student at Université de Sherbrooke in Quebec. I've had several internships in cybersecurity related areas such as the CCERT, which is the Canadian cert, GoSecure, where I worked with Francis on PyRDP, and lately in Desjardins Threat Hunting Team, a financial institution in Quebec. I'm president of JEDI, which is Université de Sherbrooke's computer science club. I really like to organize all sorts of events like workshops, conferences, competitions, and I also like to participate in CTFs in my spare time.
Hi everyone, my name is Francis. I've been an intern at GoSecure for about 8 months. So I did 4 months in the research team and another 4 months doing pen tests mostly. And I study at ETS, which is a technical university in Montreal. And I'm VP competitions for DCETS, which is our local like computer science and security club. And I'm also a CDF contestant with DCETS and Northern Coalition, our Quebecer team.
And special mention to Maxime Carbonneau for implementing several offensive features for PyRDP that we're going to talk about. He had an internship at GoSecure this summer. So the content of the talk, we're first going to talk about the context and history behind PyRDP and why it came to life. We're then going to talk about the two main use cases of PyRDP. So first using it as an internet-facing honeypot and using it offensively in pen test engagements. So when we started at GoSecure, we were given a list of ideas, of project ideas to work on, and for me and Francis, two of them were interesting to us. The first one was to create kind of a cloaking tool for pen testers. So when you're in a company's network and you want to behave, we wanted to make it look like to IT admins like we were a legitimate machine. And the other one was to work on an RDP honeypot to see what kind of what we could get finally. So yeah, the defense-offense duality was there from the start, and we thought it was pretty cool. So some people who know RDP a bit more might wonder why not this project or that project. We've identified two projects that were somewhat similar to what we built, but still different. The first one is Seth. What Seth does, it ARP spoof the network and intercepts RDP connections to basically gather credentials and possibly inject commands as well. It's a CLI tool, so it's way more limited. It's not what we wanted for a honeypot. And it does the ARP spoofing, and we really didn't want to maintain that for that specific project. The other one is RDPy, which is a pretty cool project around RDP. It implements the protocol in Python, and it records RDP session. It's really cool, but we didn't want the RDP client part, the VNC. We were mostly interested in the man-in-the-middle part of it. But we actually started the project from RDPy, and we forked when we realized that it wasn't flexible enough to implement cleanly the virtual channels. So what are virtual channels? RDP connections work with logical channels, which are called virtual channels. For the mouse and the keyboard, it's the input, and the graphics output, it's the default channel. But there are several more channels for other RDP modules, such as sound sharing, clipboard sharing, and device redirection. So you can share printers, drives, smart cards, stuff like that. Existing tools, they mostly focus on the first channel, so the input and output channel. But we were mostly interested in what we could do with those channels. So about the device redirection channel. So how are files transferred on an RDP connection? It's actually pretty simple. It's almost the same as doing it on a physical machine, but over the network. So you have create file calls, you have read files, change offset, write files, close files. What's important is that all the file operation, they are initiated by the server, and it's going to be a bit important later on. And of course, multiple requests can be sent at once, and the channel it uses completion ID to associate requests and responses to have multiple at once. For the clipboard, well, to keep two clipboard in syncs, it's actually pretty simple as well. We just need three kind of messages. So if I'm a client and I connect to an RDP server and I copy something on my machine, my client is gonna tell the server, my clipboard has been updated, and if you want, you can paste it as, for example, plain text or HTML. And the server is gonna acknowledge that. And when the server wants to paste the data, it's gonna say, okay, I want the data as plain text, please give it to me. And the client's gonna give it. And it works both ways. So from the server to the client, it's the same process. So when we started the project, we were wondering, well, RDP facing the internet, is that really a thing? And yeah, it turns out, yes, it is. According to Shodan, there are more than 5 million IPs with the RDP port open. And fun fact, when I looked, so for some reason, since Bluekeep, there are a million more IPs. Yeah, maybe most of them are honeypots. So it's still much less than SSH with 18 million, but still a big number to consider. The big challenge with RDP, of course, it's GUI based, so it's much harder to automate tasks with it versus SSH, where you can just chain commands. And we were wondering, what kind of connections would we get? Would there be credentials brute force? Would there be manual connection at all? Would they all be automatic? Would there be only service scans? And what kind of volume can we expect? Would there be 2 connections per day? 200, 2000? With those questions in mind, we implemented features for that specific use case. One of the features we implemented was to allow for any credentials to work. So since we're in the middle of the connections, we can change that. And so whenever a client connects, we can simply change the bad usernames to valid ones. So the client is connected and doesn't need to brute force. And we thought that could be useful for fully automated attacks, where credentials would get brute forced, and then upon successful connection, something nasty and automatic would happen. For the device redirection channel, well, since we see everything in the middle of the connection, whenever a file gets transferred, PyRDP can save a copy of it to disk. So say I'm a client, an evil client, and I transfer to a server evilscript.bat. Well, PyRDP saves a copy of it to disk, so even if you run it on the server and delete it afterward, it can still be retrieved with PyRDP. And obviously, we thought that could be useful for malware analysis. For the clipboard, well, we do something similar. So whenever something gets pasted, PyRDP save a copy of it, and in the replay, we can see it afterward. And recently, of course, with Bluekeep, we added log statements to build stats around Bluekeep exploits attempt. It's a pretty simple thing. So whenever the Bluekeep channel gets open, we log it and we can build stats around it. So of course, lately we've seen mostly Bluekeep exploits attempts, or at least scans on the internet. And we also log metrics about connections, so connection duration, the ratio of input-output packets. So for automatic connections or simply service scans, the input packets are pretty rare. So if you have a lot of input packets, it can mean a manual connection with someone actually interacting with the RDP honeypot. So I need to check that, or?
I actually had a pretty rough night with the party yesterday. I'm not. It is. Want want another one?
Whoa. All right. But yeah, Francis drank his fair share last night, so please respect him. He's not going to drink. Where was I? So yeah, those help identify potentially interesting connections and build statistics. So even before we had all those features implemented, we wanted to test PyRDP as soon as possible. So when we had a working version of it, we exposed it on the internet to see how it would behave against wild inputs. Our setup was pretty simple. So we had an Ubuntu VM running PyRDP that would redirect the traffic to Windows Server 2008 virtual machine with RDP enabled, but only accessible by PyRDP. So all the RDP connections that went to the Windows machine would be monitored by PyRDP. So I have a little bit of data to share. This is for about a week of data. On the left, this is the number of TCP connections per day. So at its peak, it's about a bit more than 1,000, which can seem like a lot, but I need to add that we had an entire /24 subnet redirecting to our Ubuntu VM. So this is actually 1,000 connections for dozens of machines. So it's not that much. We had some credential brute force. You can see there some of the usernames that have been tried. Obviously, administrator, admin, admin2, stuff like that. You can see the most popular one is hello. Hello is simply a lovely name for a service scanner. So just to see if we're actually an RDP server. When you connect using RDP, you send your client computer name to the server. So we can also build stats around that. We can see people using our desktop and some lead hackers using Kali. And you might wonder what this A user is about. It's Morto. Morto is an old RDP worm. So we weren't able to complete the connection sequence with it. And the RDP client, the RDP server on Windows is way more loose in allowing non-standard RDP to work. So that could change in the future and we could analyze it, but we need to tackle this shift 5 times, triggering the sticky keys executable, and then disconnect. And we found out that this is actually an open source tool on GitHub called Sticky Key Slayer that scans the internet for a specific type of backdoor where someone would replace the sticky keys executable with CMD, giving an unauthenticated shell, basically. So we thought, well, if someone scans for those things, if we compromise ourselves, maybe someone will come back. So this is exactly what we did. We implemented the backdoor, and we waited. And several days later, our VM creds had been changed, so we've been compromised. And we were all excited about that, so we come looking for the replay, and we didn't find it. And this was caused by a bug in the PyRDP that obviously we fixed by now. But fortunately for us, we add PCAPs, and PyRDP still logged the TLS master secrets. So we had everything we needed to decrypt the connection. So using PyRDP's functions, we rebuilt a replay from the PCAP, and I'm going to show you what the interesting connections were. So we nicknamed the bad actor Debbie after... So we nicknamed the bad actor Debbie because PyRDP logs different connections with a friendly name, and for this one it was Debbie. So Debbie connects and press L shift 5 times. opens the CMD and lists the users. Debbie finds out that the administrator on the machine is Baron, and then proceed to change Baron's password to adminnet1. Then, using the new credentials, Debbie connects to our machine. And looks for some basic and connects to Baron who's still connected using right click and connect. And then with a CMD, pastes a path, which is / tsclient / o.bat. And / tsclient is the path when you share a drive locally for the RDP connection. So Debbie shared its drive and transferred o.bat to the machine and executed it. So PyRDP obviously saved a copy of the file to disk, so we could review it and see what it was. That file transferred 2 other files, and it was a crypto miner and LimeRat, which is an open source rat on GitHub. And so this obviously was the last RDP connection from Debbie. After that, they used their rat. What's interesting is that they deleted o.bat, so without PyRDP, we wouldn't have a copy of the file. So yeah, manual connections after automatic reconnaissance seems the preferred first step to compromise RDP hosts. I'm putting aside obviously the new exploits, Bluekeep and such. And we've seen it used in the wild. I've linked 2 articles. The first one describes a wave of ransomware attacks where credentials would get brute forced automatically, and then someone would manually connect later and quote unquote cleanly infect a machine with a ransomware by deleting backups and stuff. And the second article is David Kennedy from Trusted Tech, who built an RDP honeypot, and it's a 3-part blog post. I recommend you read them, it's really interesting. But what's most interesting is that he faced a lot of challenges with that, and most of the challenges he faced are problems that PyRDP addresses. So seeing the replays of the connections, we do that. Saving files that have been transferred, we do that. And seeing what credentials were tried and stuff, we also do that. So yeah, we think PyRDP is a great tool to document tactics, techniques, procedures of bad actor using RDP, and that in the future we can do a lot of cool stuff with it. So now Francis is going to talk about using PyRDP offensively in pen test engagements.
All right, thanks, Emilio. So first we're going to talk about why it's relevant in pen test. Well, RDP is often used like everywhere in companies to administrate workstations and servers. And a lot of the clients that we had at GoSecure actually hadn't enabled, like, we're not using a proper PKI or using like network level authentication. And so that meant that their RDP environment was not as secure as they could be. We're going to talk more about NLA in the mitigation section, but basically it's a feature designed to prevent man-in-the-middles. Also, ARB spoofing is still a big problem, and so you can, if you have ARB spoofing, you can use it to redirect to your own VM. We're going to talk about that also. And also, as the other like more common like exploits will be, or not exploits, but like techniques will be more and more patched out, we think this is going to be a bit more of a problem. So here is the PyRDP player. This is basically like the sort of the command center, the main window for the attacker that you would use for like the manual features. So one of the features is being able to steal keystrokes and credentials. This all happens in the text box at the bottom, so you can see the key presses. And not only do we record sessions as they happen, but we also with the player you can see them happening live. So you actually have the same output as the the legitimate user. You can see everything that they're doing. And you can use this to keep traces of like what you've done to management. As, you know, if they accuse you of something wrong, you can just say like, here's the proof that I didn't do this. So we have also a feature to steal clipboard contents. So the way this works is, since we're in the middle, well, like Emilio said, the server is going to receive messages that say that the clipboard contents have changed. And then what we can do as a fake, as a man in the middle, once we receive a message that says the contents have changed, we can just inject a fake paste request. And so this paste request is sent to the user, and then this comes back to us in the man in the middle, and we see the contents, but we never actually send the response back to the server. We also have a sort of little file browser in the bottom left of the screen. And basically, like Emilio said, all the file operations are initiated by the server. This means that as a man in the middle, we can just inject fake requests to read and write files to the client. And what we do with this is we can just like browse all their files that they shared through the shared drive feature, and just download anything that looks interesting. So this is a bit how it works. Normally, if you want to look at a picture of a cat, it's the server that sends the actual request for the path and for the file. And this request is forwarded to the client. What we do as a man in the middle is we just send arbitrary file requests at any time that the attacker wants. We can also hijack sessions. We're going to do a bit of a demonstration for that, but basically you replace the client's input with your own input, and you just block their output, so to them it just kind of looks like a bit of lag or something like that. And you can possibly use this to hide your actions behind a legitimate user's actions. So like if you're monitoring the network, you don't see that another connection has been made. Since you can inject arbitrary input packets, you can just send predefined key sequences. So what you do with this is you can send a Windows R to open up the run menu and open up a CMD and just or CMD or PowerShell and just type whatever payload that you want, and then just send a fake enter key, and then your payload's going to be run. And the way that we thought you would use with PyRDP is since it's agnostic to the network man-in-the-middling technique, we talked about how we didn't want to maintain ARP spoofing. You need to use it in combination with another man-in-the-middle tool. So what we did is, well, what our colleagues did is integrated it with a BetterCap. So every time that BetterCap intercepts a connection, it's gonna launch a new PyRDP instance, and it's gonna redirect the user to the proper destination that they expect. And finally, another use case that you can use is you can redirect the connection to your own virtual machine. So obviously in this situation you don't care about the server, but you can still use it to compromise the client. So for example, you can still basically, yeah, it's used to compromise clients. So not RDP has this set of features that allows it to have this powerful impact on a client. So and one of the use cases that we sort of conceived at the beginning of this project was say you're in a dire situation, you don't know what to do, and you have a last Hail Mary, which is I'm just gonna make a lot of noise on my VM and I hope that a bunch of incident response admins try to connect to it to see what's wrong with it, and in reality you're just running PyRDP and you're stealing their credentials. And another couple of features was now you can actually see the credentials that were used on the command line if RDPDR is enabled because of details. You can also download entire folders. You don't have to go through every folder and download every single file. And we have now also an automatic shared drive crawler. So basically, When you share your drive, this crawler is going to look at every folder that's used in this drive, and it's going to match a pattern to try to find like interesting files, and it will download them to the attacker's machine. So now we're going to do a demo of everything that I talked about. So let me just power this up. So what I have, all right. So on my machine, I have this here client. This is going to be my fake RDP client, and attacker is my attacker machine. So on my client, I actually have a couple of files. You're going to see the crawler is going to download them. So here's a file called password policy, xkcd password generator, and in secret, you have password.txt and passwords, the keypass file. So the crawler is going to download all these files when a connection is made. So and you can see right now, the only thing I have in my attacker machine is PyRDP and a file that basically describes what you want to crawl. So this file just looks like this. You just use like a pattern. All right, pretty simple. It's going to download all the files that have password in their name. So I'm going to launch the player. Launch the actual man in the middle. It's not going to do like man in the middle here. It's just a demo. Basically, so we set our target here. We set the player IP, and to use the crawler, you have to use this -- crawl and pass it the text file that I just showed you. So launch that. Then I'm going to connect using. Right now, I'm using FreeRDP to connect because I'm on Linux. And I just want to mention at the top here, I'm sharing the drive that is called Home User Demo Client. So here I have at the right the legitimate FreeRDP window, and on the left you can see this is what the attacker sees in the player. So you can see everything that's happening in real time. So you might have noticed at the bottom, as I'm typing stuff, say like open Notepad, there's just text at the bottom. This is all like I said, the text box at the bottom just like shows every single key press, and at the top here, you're gonna see a log of the credentials that I used to connect. So here it's IE user and password is password. The text box, as I mentioned, is also used to steal clipboard contents. And what's interesting with that is you don't have to actually paste the data. And as long as you copy it, a message is going to be sent to the server that the contents have changed, and we can still steal the contents. So if I open for example, the key pass here, and now I'm just going to do a Control-C to copy the password, and we will see the password in the text box. So I just Control-C, go look at this, and you can see, now I can see the clipboard data, which is my password that I copied from KeyPass. And I didn't paste it anywhere. Also, I mentioned file browser here, so it's a bit small, but we have like the whole drive that was shared, so the same folders that you saw earlier, company, policy, blah blah blah, or images, whatever. So I can use that to, for example, like download the file. You can download like password.txt. You can save it there. It's probably working. All right, it's not saving. Okay, I don't know what I did wrong, but sorry, the session quit for some reason. So all right, I guess we're just gonna move to another feature. But Okay, now so we're gonna look at how the files are saved when you transfer a file on the server. So for example, now if I look at a file on my client here, if I just want to look at this image, all right, well, of course, the server has to pull that image from the client's drives. And so PyRDP sees these requests, and it's gonna save the file in the output folder. If I go here in files, I'm gonna have this smiley face here, which was just downloaded. And this is the same file that was used on the client. If I just open it up. The reason why it's called weird, like Brittany Mitchell, like that was not the original file name, but what we do is we basically give the file a unique name every time. It's useful for honeypots because, like, say you have a bunch of like malware that all use like services.exe. We don't want all these services.exe to overwrite each other, so we just give them unique names, and we have a mapping here that says like, okay, this file means like it has this hash and it came from like images smiley.gif. Right. So now I mentioned you can take control of a session. So if I click this on the attacker, I can just do anything now. Like my own mouse inputs are sent and my keyboard inputs are sent, and so I can open this up. As you can see on the right, you're not seeing anything on the RDP window because we're just blocking the output that is going to the client. So while you're doing this, the client sees nothing, essentially. And you can, for example, send the Windows R, open up a CMD or something, look at some interesting stuff. And I can just release control, and now the session's working again. And all this that we just did as an attacker, we can just go look at that. I guess it was this one, yeah. So here, everything I did since the beginning. The session cut a couple of times, so I don't have all the things in this one replay, but I have all the replays of every session. So I'm spinning it up here, but like you can see, this is what I did as an attacker. If I just scroll back here, like open up a command line, everything. So this does keep trace of what you do when you take control of the session. And so now we can go look at the crawler output. So if I go in files, it should be all the connections. So if I go, for example, in this one, you can see it created the same folder that are in the client. So here I have company, policy, password policy, funny, blah, blah, blah. And finally, it's saved the password.txt and the passwords.kdbx file. So you can just use that to automatically like get a bunch of files that could be useful for your pen test. Also mentioned PowerShell payload, so we can see that. It's a pre-recorded demo for this. So here I have I may have mentioned that there are 3 parameters to this feature. So basically, you send the payload that you want to run. You send a delay. So this delay says like I expect. For example, here we have 10,000, which means like 10 seconds. So we expect the user to be logged in within 10 seconds of like actually connecting. Then we say we expect the payload to take 5 seconds to run. So what it's going to do is block the input-output from the client starting from 10 seconds, and it's going to do that for 5 seconds while the payload runs in the background. So here's an example. I'm going to connect as the client. Of course, I will click through the certificate warning and log in, pretend to do some work, and then at some point the input-output is going to be blocked. And then in the background is running the payload. So now when the payload is done, we see the calculator has popped up. So that was for a demo. Now it's, like I said, it's used to prevent man-in-the-middle attacks. It uses CRED SSP over TLS to choose between like either Kerberos or NTLM. And so first you do a TLS handshake, then you establish an encryption key depending on what kind of authentication you're using. And then this encryption key is used to encrypt the rest of the packets that are sent. So the third step is to actually verify that the X509 certificate used in a TLS handshake is actually, like it actually belongs to the real server that is expected. I'm not going to go into details exactly, but and essentially only after the server is actually authenticated does it send the credentials of the user. So you can see how this can prevent man-in-the-middle attacks, because obviously you don't have the real private key of the real server, so you can't decrypt that, so you can't fake any of these steps. And how do you actually activate that? Well, there's in the system properties, where the place where you enabled RDP, there's just a checkbox on the bottom that says allow connections only from computers running remote desktop with network level authentication. And so if you use this, it enforces RDP, but it enforces NLA, but only on the server side. And this is by default, this is checked in the more recent Windows versions, so Windows 8 and the following. However, we found like many companies that still had like that didn't enforce NLA because for some reason, like either they unchecked the box or they maybe the original configuration stayed over the years. And so you can, but to enable it on every client or on every server, you can just use a GPO to check this on every client and on every server and make sure that every server uses NLA. There's also a trick that we think you can use to enforce NLA on the actual clients. And so there was a feature called restricted admin mode that was introduced. So what this does is it allows you to authenticate without actually sending your password in clear text. And for this to work with RDP, it has to use NLA. So if you just enforce this on all the clients, technically it should enforce NLA everywhere. So if you combine this with the GPO for enforcing RDP, enforcing NLA on servers, you should technically be protected. Another possible thought would be to mitigate R spoofing. Obviously, it's not that simple because it's a complex protocol and I think it's broken. But you can still use like some non-perfect solutions to just at least like mitigate a part of the damage. Like if only you're catching 20%, that's at least better than catching like 0%. But obviously it's a hard problem. There's no perfect solution. The ideal situation would be that you just have proper public key infrastructure everywhere. So because no RDP connection should raise the certificate warning. And if you actually see this, it should be a major red flag. But like it's not usually done, and it's not been done for years and years. So users are just like have trained themselves to just click through these warnings. Hopefully with a proper PKI, you can sort of remove this desensitization away. Of course, some users are always going to click through warnings no matter what. So I think you should like probably do some sensitization to try to minimize the proportion of users that actually click through these errors. So now I'll let Emilio finish with the next steps for PyRDP.
So PyRDP is a pretty recent project, so we didn't implement everything we wanted to implement. So those are some ideas as to what might be coming next for PyRDP. First, better clipboard support. So right now our clipboard support is basic-ish in the sense that we don't support file pasting. If someone pastes a file on the server, we don't save a copy of it to disk, but we should and we can. So that could be a nice addition to PyRDP. Obviously for malware research, if someone pastes a file instead of using it with the device redirection channel. Retrieving replays and files from PCAPs. So as I said earlier, we built a script to rebuild replay from a PCAP, but we could do something that's more scalable, that takes PCAP as an input and necessary decryption material to list RDP sessions, recover files that were transferred, and create replays of sessions. And we thought that could be useful for incident response if you're recording the traffic and have access to the TLS secrets. Obviously, that won't work if you use proper encryption. So encryption with the perfect forward secrecy property. Use that, and that makes it so the private key is not enough to decrypt the connection. Uploading files on the client file system, we thought about that. We thought it was pretty cool since, as I said earlier, the server always initiate the connections. The server, PyRDP can say, well, upload this backdoor.exe to your startup folder. And since the Windows client forces the user to share a full drive when they connect to PyRDP and they want to share a drive, you can just say, I want to share this folder. You need to share your whole C drive. So the startup folder should be accessible most of the time a user shares a drive. So it makes redirecting RDP to your own VM more valuable. PyRDP is an open source tool on GitHub. We welcome any help from the community, so if you try PyRDP and you have success with it, please tell us. We want to hear your stories about how you got DA with PyRDP. If you have issues with it, please open an issue on GitHub. We usually respond pretty fast to them. And if you find some niche use cases for PyRDP, please tell us. We're going to be glad to hear it. So thanks, everyone. Do you guys have any questions? Yes.
It does like. Sorry. So the question was, when you take control of a session, does the user session basically freeze? Right. It does like freeze the session, so they can send input and like cancel what you're doing. I think this is obviously not something that you would use like on every session, because obviously it's very obvious if you're doing that and you're doing work for like 5 minutes. I think it's mostly like you can use it if someone appears to be idle and run a quick payload. So what you can do is type. There's also in the menu you can select some text to paste, and it will just like paste it like really fast to the session. So you could like run a command line and just paste the command that you want. And so that would be a good way to use it really quickly. But it does freeze the sessions.
Yes. So the question is, if you freeze the session for long enough, will the client time out? The answer is no. So we still respond to the packets. We just block the graphical output and we block the input to the server. So no, it doesn't time out.
Maybe want to add something. So like basically, there's no confirmation that the inputs that you're sending from the client are actually received by the server. So PyRDP is just a single for like all the input, and the client doesn't know that it's not actually going through. So it just plays along like dumbly and doesn't like never figures it out.